Hi guys, and welcome to today's lesson on 7-4. So for today, our objective is students will multiply powers raised to another power and solve the product of powers. And our essential question, what happens to the exponents when a power is raised to another power and when the base of an exponent has more than one variable in it? So if you need to pause the video at any time, please make sure to do so. Whenever you need to write some things down or things like that, make sure to pause this video. I'm going to get moving forward here. So to start, we look at these two problems and we want to see if there's a pattern, right? Notice we have 3 to the 4th power in parentheses, and then it's raised to the 2nd. So, right, this is that idea of a power to a power. So let's think of, right, this 2 is saying we have 2 of these, so 3 to the 4th times 3 to the 4th. And if I want to break down 3 to the 4th, it's really 3 times 3 times 3 times 3, then times 3 times 3 times 3 times 3. So I'll make this here. Right, that's that problem broken down. And if we really want to count this, this is really the same as 3 to the 8th. 3 to the 8th. So let's try it again over here. Right, this 5 is telling us we have 5 of this thing. So 1, 2, 3, 4, 5. Right, what this is going to be, right, if all of those are m times m times n, we count the total number that there are, right, 3, 6, 9, 12, 15. So a total of 15 m's. So we're looking at this, we're trying to figure out, is there a pattern? Do we notice, right, 3 to the 4th, then squared, we got to 3 to the 8th. M to the 3rd, then to the 5th, and we got to m to the 15th. So we're going to try to see, is there a pattern? Maybe we're starting to see that right now. Right, that pattern here is if we have a power to a power, you multiply the exponents. So notice this example here, m to the n, we now just write it out as m times n. We multiply those exponents. So let's do an example here. We have x to the negative 3rd raised to the 4th power. Well, what that means is we multiply these together. This gets us x to the negative 12th. But for all of the things that we do in this class, right, we want to simplify. That means no negative exponents. So that means we're going to have to rewrite this as 1 over x to the 12th. So we got one more example down here. So we got power to a power, so let's focus on that. We'll just bring this down first. So now we have 4 times negative 10. So that gives us negative 40. All right, when we multiply values together, we add our exponents, right? So these two will be added together. So this really gives us m to the negative 38th. To the negative 38th. Well, if we have a negative, again, just like the problem up above, we have to move that, bring it down to our denominator, and now it is positive. So we have 1 over m to the 38th. Again, if at any time you need to pause this video, please do take your notes on it. Make sure we're taking good notes here. I'm going to move forward again. So some quick examples here with you guys. What I'd like you to do at this point, pause the video, try these 2 problems. I'm going to go through them real quick here, but pause this video and try these 2. So if we do this first one, n to the 2nd, then raised to the 4th, right? 2 times 4 gives us 8. Next one here, negative 2 fifth. We multiply those numbers together. We get y to the negative 10th. But we never leave negative exponents. So it's 1 over y to the 10th. So now the question is, what happens when there is more than one variable in a base? So we look at this base, right? We have 4 and we have x. And we have that all raised to the third power. What this is really saying, we can think of it this way, is it's saying we have 3 4 times x's. Well, right, let's focus on just the numerical values, the coefficients first. 4 times 4 times 4, right? 4 times 4 is 16, times 4 is 64. X times x times x gives us x to the third. Right? Maybe we notice a pattern here. We're going to try one more. Okay, let's do the same thing here. We're just going to write this out twice though. So 2xy times 2xy really gives us 4 x squared y squared. So again, maybe we're starting to notice a pattern. We're going to talk about that pattern here on the next page. So that pattern is that to raise a product to a power, raise each factor to that power and then multiply. So notice if we have something like AB to the n, you can kind of think it as distribution, right? We're distributing that n to both terms. And so we have our example here, right? We distribute that 4 to each one, and then if it was a numerical value we could solve, we had to figure that one out. So let's try number 1 here, right? Think about distributing that. This is really 3 squared x squared, which would give us 9x squared. Okay, now we got this one here. So we have 6m to the negative 2, n to the third, z to the second, all raised to the fourth. So I'm going to bring that to each and every term. So now I have 6 to the fourth, m to the negative 8, right, because negative 2 times 4, n to the positive 12, z to the positive 8. And so we got a couple of things we have to do. First, we got to rewrite this as 1,296. And now we look and see, do we have any negative exponents? Right, we do. And so we know that one has to come down to now our denominator. We have to move it from the numerator to the denominator. So now if we look at our other two, right, positive, positive, those just stay right where they are. And that would be our final answer. So a couple examples here for you guys to try. Again, if you'd like to pause the video, work on these first. I will go through these real quick here. And last one down here. I'm just going to rewrite that. Combine these. We add them if we're multiplying them. So this is c to the negative 18, d to the positive 8. This one's going to stay, but that c is coming down here. So hopefully we can check our answers there. And that is it for today's lesson. on 7.4 product of powers.